Hi there, it's Mrs. Bogus again. Today I'm going to talk with you about linear relationships. Part of this will be a review, but a majority of it will be new information. We're going to discuss how linear relationships are important to statistics. In your packet, you have this scatter plot. This data shows the finishing time in seconds on the y-axis and the years after 1900 for the Olympic gold medalists in the men's 100-meter dash. You'll also notice there's a line on this graph. This is the line of best fit, and it does just what it says. It is the line that best fits our data. The equation for this line is right here, and I know it looks a little intense, so we'll break it down here in a little bit. But you may be wondering what this little roof hat type thing is, and it's just that. It's a hat. This symbol means the predicted value. So really, this line is telling us the predicted values for finishing times. We can tell from looking at the scatter plot that not every point is on that line, which is why this line is just a prediction. While we're talking about it, let's review what a line of best fit or an equation of a line is anyway. The equations on the screen should look familiar to you. These are models that you've used this year and also in Algebra 1 to write equations of lines. During this statistics unit, the calculator will do the actual writing for us, and you'll learn more about that later in this packet. But our main concern with the equations is interpreting the slope and the y-intercept. At the bottom of your page, you'll see a table. Over the next couple of slides, I'm going to help you fill in the table. Feel free to pause the video at any time to write information down. So we're going to start with slope. In general, slope tells us how our y data is changing per 1x unit. When we interpret the slope, we are always going to use this phrase. So hint, hint, I'd write this down. You'll see a lot of blanks in here, and as I go through that, I'll fill them in. So to interpret the slope, we say, word for word, for each 1 x unit increase in the x-axis, the y-axis increases or decreases by whatever the slope is. So the words that are up here in blue are what you're going to fill in specific to your data. It's just really important that it follows this phrase each time we're talking about slope. I'll give you a couple minutes, or you can pause to write this down. So let's continue with that table. First, when we're interpreting, we need to be able to identify the slope. The slope for this equation is negative 0.0106. There should be an extra 0 right here. I apologize. And as a side note, you'll notice that the slope and y-intercept are flipped in their order from what we normally work with, and that's okay. So what does this slope mean in context? Now remember, I'm using the phrase from the slide before, and I've filled in the appropriate terms or numbers. So in this context, our slope means for each 1 year increase in years since 1900, the finishing time decreased by 0.0106 seconds. So I have my x unit, which is years. My x-axis was years since 1900. My y-axis was finishing time. It decreased since our slope is negative, and my actual slope was 0.0106. So moving on to the y-intercept in general, that tells us the starting point or the initial value, and those two are interchangeable. For our data, we can identify the y-intercept as 10.878, and what that means in this context, or our interpretation, is that the finishing time in 1900 was 10.878 seconds. And I say 1900 because that is where our data starts. Here's another example for you. You don't have this one on your sheet, so just take a look at what I have on the screen. Interpret the slope and y-intercept for the cost to rent a car with the equation predicted cost equals 19.99 plus 0.25 times miles. First, we need to identify our slope, which is 0.25. And what that means is, and again, I'm using my phrase, for each 1 mile increase in miles driven, the cost increases by 25 cents. The y-intercept is 19.99, and that means that the cost to rent a car and drive 0 miles is $19.99. So for this one, the starting value or our initial value would be when we haven't moved the car at all. It's that initial cost. So continue on in your packet. There are a bunch of examples coming up about interpreting slope and y-intercept. And feel free to come back to this video if you have any questions or need more clarification. Thanks for watching.